Welcome to this comprehensive tutorial on C-sharp async/await, tasks, and multithreading, designed specifically for beginner programmers looking to enhance their application development skills. Have you ever encountered an application that freezes or becomes unresponsive during a long operation, leaving users frustrated? This tutorial will equip you with the knowledge to prevent such issues. We'll explore async/await, tasks, and multithreading in C-sharp as powerful, modern tools to significantly enhance application responsiveness, improve overall performance, and create a smoother user experience. This guide is tailored for beginner programmers with foundational C-sharp knowledge, providing a clear, step-by-step approach to understanding and implementing these essential concepts in your projects. Our journey will cover what tasks, async, and await are, why they are crucial for modern applications, basic multithreading principles, and practical applications in both Visual Studio and Unity. We'll also delve into best practices to ensure you write efficient, maintainable, and robust asynchronous code that stands the test of time. Let's begin our deep dive by understanding what tasks, async, and await truly represent in the context of C-sharp programming. A task in C-sharp represents an asynchronous operation, essentially acting as a promise that some work will be completed at a later time, without blocking the current execution. It's a core component of the Task Parallel Library, or TPL, which is designed to simplify and streamline concurrent programming in .NET applications. Creating a simple task involves defining the work to be done, which can then be executed asynchronously, allowing your program to continue with other operations. The async keyword marks a method as asynchronous, which is a prerequisite for enabling the use of the await keyword within its body. The await keyword pauses the execution of the async method until the awaited task finishes, crucially, without blocking the calling thread, thus keeping your application responsive. It's important to remember that await can only be utilized inside a method that has been explicitly declared with the async keyword. Here's a basic code example demonstrating async and await in action, simulating a simple asynchronous operation. This task, delay, simulates an asynchronous operation, such as fetching data from a network or performing a complex calculation that takes some time to complete. Now, let's explore the compelling reasons why you should integrate async/await and tasks into your C-sharp projects for modern application development. One primary benefit is maintaining UI responsiveness, preventing long-running operations from freezing your application's main thread and ensuring a smooth user experience. These techniques also significantly improve efficiency by effectively utilizing system resources, leading to better overall performance and faster execution times. Async/await simplifies asynchronous code, making it read and behave much like traditional synchronous code, thereby reducing complexity and improving readability. Common use cases include fetching data from APIs, reading or writing files, performing database operations, and executing complex, CPU-bound calculations. Consider a simple UI demonstration. Without async/await, the UI freezes. With it, the UI remains fluid and interactive, providing a seamless user experience. Next, we'll cover the fundamentals of multithreading, a concept closely related to asynchronous programming and crucial for parallel execution. Multithreading is the ability to execute multiple sequences of instructions or threads concurrently within a single process, maximizing CPU utilization. Threads are lightweight, independent units of execution, offering improved performance, responsiveness, and efficient resource utilization by dividing work. While a thread is a low-level operating system construct representing an actual OS thread, a task is a higher-level abstraction representing an asynchronous operation, often utilizing thread pool threads for efficiency. You can create a new thread using the system threading namespace, as shown in this straightforward example. It's crucial to briefly touch upon thread safety, ensuring that shared resources are accessed without causing race conditions or data corruption, which can lead to unpredictable behavior. Now, let's see async/await in action within a practical Visual Studio environment, demonstrating real-world application. We'll set up a new console application in Visual Studio to demonstrate downloading data asynchronously from a web source. Our example scenario involves using HTTP client to asynchronously download a string from a URL and then displaying the retrieved data in the console without blocking the main thread. Observe this code snippet for asynchronously downloading data, highlighting the key async and await patterns. This demonstrates how async and await keep the application responsive even while waiting for the data download to complete, ensuring a fluid user experience. We'll also explain configure await and when it's appropriate to use it to avoid potential deadlocks, especially in library code. Next, let's transition to applying async/await concepts within the Unity game development engine, showcasing their utility in interactive environments. We'll begin by setting up a new Unity project to illustrate asynchronous operations in a game context, such as loading assets without freezing the game. Our example involves asynchronously loading a texture from a URL using Unity Web Request Texture.getTexture, a common task in game development. The loaded texture will then be applied to a game object in our Unity scene, updating its appearance dynamically. Here's the code for asynchronously loading a texture in Unity, demonstrating how to integrate web requests with game objects. This demonstrates how to update the UI, specifically a GameObject's texture, on the main thread after the asynchronous operation completes, ensuring smooth visual transitions. We'll also briefly mention Unitask as a more efficient and Unity-optimized alternative to standard tasks, offering better performance in game loops. To maximize the benefits and avoid common pitfalls, let's discuss some essential best practices for async/await in your C# projects. Always use the async suffix for your asynchronous method names to clearly indicate their nature and improve code readability. Avoid async void methods, except for event handlers, as they can make error handling and task tracking more challenging and lead to unhandled exceptions. Employ configure await in library code to prevent deadlocks and enhance performance, especially in UI-heavy applications where context switching can be costly. Implement robust exception handling using try-catch blocks to gracefully manage errors in asynchronous operations and prevent application crashes. Utilize cancellation token to enable cooperative cancellation of long-running tasks, providing users with control and improving application responsiveness. Minimize async/await in performance-critical sections. Consider alternative designs or tasks. Run with caution for CPU-bound work to avoid overhead. Never use, result, or wait on asynchronous operations, as this can lead to deadlocks and unresponsive applications by blocking the calling thread. Efficiently combine multiple tasks using task.run to wait for all of them to complete concurrently, optimizing parallel execution. In summary, we've covered the core concepts of tasks, async, await, and multithreading, along with their practical applications in C#. These techniques are invaluable for creating responsive, high-performance applications and games in C#, providing a superior user experience. We encourage you to practice and experiment with these concepts in your own projects to solidify your understanding and build confidence. For further learning, explore Microsoft Docs and various programming blogs for in-depth resources and advanced topics. Thank you for watching this tutorial. If you found it helpful, please like, subscribe, and leave any questions or comments below.